Torque acting on an electric dipole in a uniform electric field. We have an electric dipole AB which has been kept in a uniform electric field E, which is directed from the left to the right side. Length of the dipole is AB, which is having a value of 2L. O is the midpoint of the dipole. So AO is equal to OB is equal to L. We have a perpendicular which is drawn from A to the point say N. Now since the dipole is making an angle of theta with the horizontal, so angle ABN will be equal to theta. And also AOM will be theta, being corresponding angles. Now since there are two charges plus q and minus q in the dipole, so some force will act on the plus q charge. If we denote it by Fa, that will have a value of q into E. Q is the charge and E is the electric field. And we know that on the positive charge, the force acts always along the electric field. Similarly, the force on the charge minus q, if we are denoting that by Fb, that will again be equal to q into E. But the direction of this force will be opposite to the electric field. So the net force F will be the sum of the force Fa and the force Fb. And since Fa and Fb are directed in the opposite direction, so when we will write that in terms of magnitude, we will get F is equal to Fa minus Fb. Since Fa and Fb both are equal to Qe, so F can be written as equal to Qe minus Qe, that is 0. So there is no net force on the dipole in a uniform electric field. So whenever a dipole is kept in a uniform electric field, the net force will become equal to 0. Now these forces Fa and Fb, they were oppositely directed. But since they have having a different line of action, so these two forces will constitute a torque and torque will be produced. And the formula for torque is always given by torque is equal to force into perpendicular distance. The perpendicular distance is An. So we can write sine theta as equal to the perpendicular distance, that is An, divided by hypotenuse, which is 2L. So An can be written as equal to 2L sine theta. So the formula for torque will be equal to Qe into 2L sine theta. Now since we know that Q into 2L is electric dipole moment, so we have taken Q into 2L as one term into E sine theta. So the formula for torque will become P into E into sine theta. This can also be written as vector tau is equal to vector P into vector E. That is, the torque is the cross product of electric dipole moment and electric field intensity. Now in case the dipole is kept parallel to the electric field, then theta will become 0, so torque will also become 0 since sine 0 is 0. In case the dipole is kept at an angle of 90 degree with the electric field, that is, it is kept perpendicular to the electric field, then since sine 90 is maximum is 1, so the torque will become maximum, that is Pe sine 90, that is Pe. From here we can also define the electric dipole moment. We can write electric dipole moment P as equal to tau maximum upon E. That is, the electric dipole moment can be defined as equal to the maximum torque provided the electric field is unity.